Okay, now we're going to do a kinematics problem involving a train. So let's read this very carefully and then start analyzing them one by one. We have train A here going to the right at an initial velocity of 44 meters per second. And then we have train B going to the left at an initial velocity of 58 meters per second. And then the distance between them, between their front edges, is 260 meters. So we have different questions here with different scenarios, and we want to answer these. A says if train A decelerates at a rate of 6 meters per second squared and train B decelerates at 14 meters per second squared, will they collide? So assume two trains see each other and immediately they hit their brakes when they are 260 meters apart, okay? One is decelerating at 6, the other one is decelerating at 14, okay? So if the collision happens, if yes, where and how fast is each one moving? So I want to know if they do collide, how fast is each one moving and where do they collide, okay? If no, how far apart do they stop? So do they decelerate fast enough to where they stop? And then what is their distance between them? Okay, so we're assuming in this question A that after each one stops, people are going to be evacuating. So the trains aren't going to stop and move backward, okay? They're not going to decelerate after stopping and then change direction and accelerate in the opposite direction. So they're just going to stop, people are going to evacuate, okay? B is a different scenario. B says if train B is unmanned, so imagine you see a train and is loose caboose, right? It's headed toward you. So some runaway train, it's coming toward you, it's unmanned. And let's assume that it's coming toward you at constant speed of 58 meters per second, right? How fast should train A decelerate to barely avoid a collision? So what he's gonna have to do this time, if train B is coming constant speed, this train has to decelerate really fast. It's gonna have to come, stop, then go back, and then barely avoid a collision. So just, they can tap each other very gently, but just barely, so that they're basically gonna be going backwards this way. Then there's gonna be a tiny tap, and then after that, train A is gonna keep going faster and faster, and then there's gonna be no serious collision between them, right? So C is a little different scenario. In C it says, if train B is unmanned again, how fast should train A decelerate so that they can stop? So this time I want train A decelerate, stop, and not return backwards. Stop, and people have 3 seconds to evacuate. I mean, that's very fast, but we could do it. Maybe there's only a couple people in the train. In 3 seconds you get out before being hit. So here it says, how fast should train A decelerate so that they can stop and have 3 seconds to evacuate before being hit by train B? So the same problem, the same scenario, very different questions. Okay, so let's set this up. So let's start with A. Okay, write down what is their acceleration, right? If this one is moving to the right and they're decelerating, that means their acceleration is opposite to their velocity. So their acceleration is this way, right? What is their acceleration? Negative 6 meters per second squared. Why? Because everything left, I'm considering negative, right? I'm putting my x and y axis here in the front edge. Everything here, this is my origin. Everything this way is positive, including the velocity. If the velocity is this way, it's positive. Acceleration is that way, it's negative, right? Now, if this one is moving to the left, the velocity is going to be negative, right? Because the velocity is to the left, negative 58. But they're slowing down, that means the acceleration is to the right, right? So just because you're slowing down doesn't mean your acceleration is negative. Slowing down means your acceleration is opposite to the direction of your velocity, right? So if your velocity is negative, your acceleration will be positive. And what was the value? 14 meters per second squared. Okay? So now the first thing I want to do in this case is find out how many seconds each train takes to stop by themselves. if the other train didn't even exist. I want to know how many seconds it takes them to stop. Then I'm going to set up an equation to see if they collide with each other before any of them would have stopped. Okay? So how many seconds does it take this one? V final train A is equal to V initial train A plus AT, right? V final train A is 0. V initial is 44. Acceleration is negative 6t. That means train T is going to take 44 over 6 seconds. So what is that? 7.3333 seconds. Train A would have stopped in 7.333 seconds if train B didn't exist. Okay? So now, train B, the initial train B plus AT, 0. Initial velocity of train B, negative 58. Initial velocity of train B, negative 58. Acceleration of train B, 14. So T is equal to 58 over 14. 4.143 seconds. So this train stops naturally in 7.33 seconds. This one, 4.143. Now I want to see, do they collide in less time than it takes for either of them to stop? Does it take them less time? Okay? If so, then the collision happens in that given amount of time. Okay? So let's see here. How do we set that up? We're going to set up an equation for the motion of the train A. X final train A equals X initial train A plus V initial train A T plus half acceleration of train A T squared. Right? So this is going to be some equation. What's X initial of train A? Well, I'm putting the coordinate right at the front of train A, so 0. V initial is going to be 44t plus half A negative 6. So it's going to be 44t minus 3t squared. Okay? So now we're going to set up an equation for the position of train B. X final of train B. I'm going to just, instead of writing the general equation, just answer. What's the X initial of train B? 260, right? What's V initial train B? Negative 58. What's acceleration of train B? 14. So I'm going to do half of 14, right? 1/2, 14 t squared. 260 minus 58t plus 7t squared. Okay, so what am I going to do then? Let's erase this. Over there becomes positive 3, 10t squared. 44 goes over there, becomes negative 44. So it becomes negative 4 and 8 is 12, 1. 6 and 4 is 102t. 260 stays there. Right? Now solve the quadratic equation and you get the answer. Okay? So let's put this into the solver. Okay, now let's try to make sense of what does this answer mean? And is it a legitimate answer? 5 and 5.2 seconds. Well, wait a minute. Look at this times. This train stops in 7.33 seconds. This train stops in 4.143. If the train is stopped, how can the collision happen in 5 or 5.2 seconds? The train is stopped. So what is the meaning of this answer then? What does that mean? Well, let's see. The equation doesn't know that when the trains stop, that people are going to be evacuating, right? The equation thinks the trains are going to stop and turn around and accelerate the other way, right? So the equation thinks something like this is going on. So this comes, and in 4 seconds it stops, right? And then after 4 seconds it stops, it starts to reverse and accelerate the other way, right? This one slows down, slows down, slows down, and it takes them 7.33 seconds to stop, right? So that means it takes them a lot longer. So while this one has stopped and is returning, this one is slowing down, slowing down, slowing down, slowing down. What does the 5 seconds mean? Somewhere over here, after this has already returned, while this one is headed backwards, this guy is slowing down, but hasn't stopped yet. So in 5 seconds, this guy is going to hit this guy. If this one returns back and accelerates back. So what is the meaning of the 5.2? The 5.2 basically means if these things were on different lanes, two trains on different lanes, see, it looks like this, like that, 5, and then once it hits it at 5, it's going faster, you see, like that, 5, like that, and then comes back, 5.2, they meet up again. So the meaning of the second answer is, if these things are happening at different lanes, they pass each other at 5 and 5.2, okay? But is either of them the legitimate answer? No, because one of the trains has stopped at 4 seconds and people are trying to evacuate, right? So that means that answer 5, we can't accept it. So the next thing we have to do is to say this. When this train stopped at 4.143, where did it stop? And how long will this guy take to get there? And then that will answer our question, you see? 60, here negative 58, and then into the t, let's put the time that it takes train B to stop, which was 4.143 seconds. 4.143, put here 14, 4.143 squared. When we put that all in, we get 139.857. 139.857 meters. So train B has stopped 139 meters from where this train was. Remember, the original distance was 260. So now, how long will train A take to get to that point? Train A is equal to V initial train AT plus half AT squared. And we can solve the quadratic again, and we can get the answer. The answer comes out 4.6577. 4.6577 seconds. Does that make sense? In 143 seconds. In 4.143 seconds, this train has come here. People are trying to evacuate, right? You take 4.6577 seconds to get there and hit it. Does that make sense? Oh yeah. See, they stop first. You take a little bit longer and to hit it. So if people were trying to evacuate, how long will people have to evacuate? You subtract this minus this, right? 4.6577 minus 4.143, okay, something like 411, they have 1/10 of a second, right? So, okay, so that's not much time at all. So the smarter thing would have been for train B to not just stop, but accelerate the other way, and at least maybe have a chance, okay? And we solve it, we put it in solver, and there's no answer. The answer is imaginary. What would that have meant? That would have meant both cars, both trains stop at a certain distance from each other, and the collision never takes place. So it goes like this, like this, like this, stopped, stopped. How would we know that they both stopped and no collision happens? We would get no answer to the quadratic equation. We would get imaginary answers, right? Then we would have to find out where are they stopped. So we can go back to the equation, find out where each one is stopped, and then subtract where they have stopped, and we know what is the distance between the trains when they stop, okay? So depending on the scenario, either they're both hitting each other while they're moving, okay? They hit each other, they're both moving. One of them is stopped, the other one hits that one, or they both stop and then there's some distance between them, okay? So now we go to question B.